All dying to see the answer to the Monty Hall problem, and I will explain it right now. So the premise of the problem was you had three doors to choose from, and you choose one door, and that's your choice, right? So I'll mimic that, and for time's sake, we'll just choose door number one as the door that you originally chose. All right, now let's talk about math before we move on to the next step. Um, so I guess if we're just talking percentages or chances of winning the game, there's three doors, and every single door, I guess, technically has the same amount of a chance to be the one with the car behind it. Therefore, each percentage kind of works out to be 1/3 of a chance to win. So the first door has a third of a chance, the second door a third of a chance, the third door a third of a chance. This actually works out to 33.3% if we convert it to a decimal. Now, we chose door one. That means that door two and door three could hold the car, and combine, if we add up door two and door three's percentages, we'll put it under a little arc here. We combine 1/3 plus 1/3 and 33.3% plus 33.3%, you actually get 2/3, or a 66% chance, or 66.6% chance that the car is behind either door two or door three. So a higher chance as opposed to the door you chose. Now, the way the game works, I allow you guys to look behind one door, and I opened up, let's say, door two, and there was no car behind there, which leaves only door one or door three as our possible options. Now, based on the fact that I took away one of the doors, all of this 66.6 and 2/3 of a chance now gets put onto door three. So there's a 66.6% chance the car is in door three, and a 33.3% chance the car is in door one. Now, my question that I ask you is, do you want to switch doors? Would you like to open up door three as opposed to door one? The logical response here and the answer to the question is yes. You should switch choices or doors to open door three. Now, granted, this doesn't necessarily mean the car is behind door three. You might have been an outstanding guesser, and the car might be behind door one, and you should stay with your door one choice if you think you've selected correctly. However, if you were to repeat this process over and over and over again, and the car was randomly put behind any of the doors to start the game, your best solution or your best choice would always be to pick a door, let the game show host open one of the remaining doors that does not have the car, and then switch your selection to the door that you originally did not choose, leaving you with a higher percentage of having the car. Okay? So yeah, you should actually switch your choice. All right? But realize there's really no absolute correct answer to this problem, because it is a game of luck. And you know, you have to kind of play the game in order to win. Okay, now I'm going to show you one more thing that I thought was interesting. I don't know if everybody's going to quite understand this next point, because it is a little bit abstract, but I'll do my best to explain it to you. So I'm just going to add another little page here if I can. There's that page, add it, and check, save. And there we go. Now, let's say that I'm gonna draw a bunch of little squares here. All right, so let's say here's a door, a door, a door, and there's 5, 6, 7, 8, 9, 10 doors. Let's add another couple of doors here. And let's say there's 20 doors to choose from now. And you're going to stick with choosing door number 1, let's say. 12. And you've chose door number 1, and you say, that's my selection. Okay, so out of all of these choices, each door has a 1 in 20 chance of being the door with the car behind it. All right, this actually converts to a 5% chance of actually having the car. Okay, if you divide 1 by 20, you get 0.05 times 100 gives you a 5% chance that door 1 holds the car, or door 2, or door 3, or so forth, that any single door holds the car. Now, if I'm looking at this, that means every other door here, if I was to add all those percentages up, there's a 95% chance that the car is in one of those doors. All right, now, me being the game show host, I want to help you out. I want to eliminate some of these choices to hopefully make you want to select a different door. Let's say I take out 3, 4, I've taken out these doors, and I leave you with 1 door to choose from. And I opened up all the doors I just crossed out in red. None of them had the car. And I left you 1 door to choose from, door number 7. All right, now, door number 7, being that I opened up all the other doors, still holds the 95% chance that it's behind that door. Okay? So now I'll ask you the same question. Would you want to keep your door that holds only a 5% chance of having the car, or would you want to change your door and choose the door that has a 95% chance of having the car? Now realize 5% is a lot less than 95%. And to have a 95% chance of winning would be much more ideal than having your 5% chance of winning. So most of you, I would say all of you, would most likely switch doors in this case. Now watch what I'm going to do here. The 33% chance that you have winning when you looked at door number 1 as compared to the 66% chance you had winning if you were to switch over to door 3. Let's get back to my page. 33% is still less than 66%, but the two numbers here are semi-close, which may make you not want to switch doors. It's obviously not as clear as that difference between 5% and 95%. But realize, you should always play a percent game. If you're going to give yourself a greater percentage of winning, you should always make that change. All right, now I hope that made it a little bit more obvious, just looking at it as a bigger picture problem. Okay, but again, the final answer should be, yeah, you should switch doors, and you should do that every single time. The game host is cutting you a break. All right, so I hope you guys enjoyed the problem, and Some of you posted really good responses. I'm happy with the results. All right, and maybe I'll post one later this week on Friday. Another little brain teaser for you. All right, have a good day.